The last section covers questions 14 to 18. Alex believes that for the linear function f of x equals 50x and the exponential function g of x equals 2 to the x power, the value of f of x is always greater than the value of g of x. Glenda believes that for the linear function f of x to always be greater than an exponential function g of x, the graph f of x must be very steep, while the graph of g of x must be very flat. She proposes graphing f of x equals 50x and g of x equals 1.1 to the x power to test her conjecture. Test Alex's conjecture by graphing f of x equals 50x and g of x equals 2 to the x power on your graphing calculator. Do you agree with Alex's conjecture and explain your reasoning? I'm working on clearing everything out of my calculator, and I'm going to graph those two functions. It was 50x, and then the next one is 2 to the x power. And I'm actually going to go to my window. Sorry, not my window. I'm going to do zoom, and I'm going to go to the standard set, which is 6, and it does a negative 10 to 10 ratio. I see a blue line in here. All right, so I want to clean that up a little bit because I see this blue line going here, and I have this like red curve going here. So I want to kind of clean that up. So we're actually going to change my x and y mins. I'm going to go -5 to +5 and see what happens. Now let's graph it. Okay, so I see that it's still kind of really close to the y-axis. So let's do, window. We'll go -1 to +1. Oops. Now let's see what happens. Oh, now I'm seeing some contrast here. Okay. So let's see what happens here. It looks that for some part of this line, the line f of x is greater than the curve g of x, but not for all of it. So I'm going to put some portion of f of x is greater. And some portion g of x is greater. Let's take a look at 14b. Now adjust the viewing window to match the coordinate plane below and sketch the graphs of f of x and g of x. Okay, so we want to go from 0 to 10 on my x. So 0 to 10 on my x, going up by ones because it counts every one. And then we're going to go from 0 to 500, going up by 50s on my y. It's actually a pretty good graph of both. So we got 50x okay. Okay, and now we want to graph the other one, which is 2 to the x power. It's about 250. 2 to the over 50. All right. So this is my g of x, and this is my f of x. All right. Should Alex revise his conjecture and use the graph in item 14b to explain? Now remember, Alex believes the value of f of x, so the value of the line, is always greater than g of x. So the line is always bigger than the curve. Yes, we should revise it. The graph shows that somewhere between x equals 7 and x equals 8, g of x overtakes f of x. Because at some point between here and here, this line gets to be above the line. The curve is now above the line. Test Glinda's conjecture by graphing f of x equals 50x and g of x equals 1.1 to the x on your graphing calculator, and do you agree with Glinda? So we're going to change this to say 1.1 to the x. Now Glinda says the linear function is always greater than the exponential. Well, based on this picture, it looks as that is true. But if I change my window, I'm guessing that's not going to be true. Let's do a zoom standard window and go back to the original graph. And again, we'll see some portions where g of x overtakes f of x. So some sections f of x is greater, while other sections have g of x greater. B. Now adjust your viewing window to match the coordinate plane below. Sketch your f of x and g of x. Okay, so now we're going to go from 0 to 100 counting by tens. And then we're going to go 0 to 10,000 counting by 1,000 and graph it. All right. Okay, we're going to graph this line. And then I'm going to do 1.1 to the 20 is about 6. So it's going to be really, really low. And 1.1 to about the 40 is about 45. 1.1 to the 60 is about 300, so we're getting closer. 1.1 to the 80 has now crossed to about 2,000. So it's going to be right about here. 1.1 to the 90 is at 5,300, so that's about up here. 1.1 to the 100 is off my chart, so I can't graph that. But it looks like it's going to do something like this. Something similar to here. This is g of x, and this top one right here is f of x. All right, should Glenda revise her conjunction, use the graph from item 16b to support your response. Somewhere between 80 and 90, the graph shows that somewhere between x equals 80 and x equals 90, g of x overtakes f of x. Attend to precision. Is an exponential function always greater than a linear function? And explain. No. As shown on both graphs, there are sections where the linear function has a higher value, should say greater value, than the exponential. On to the wrap up of this lesson.